This is Module 15, Section 8.1. To start this module, we're going to review equation forms of a line. In Math 920, Module 9, several equation forms commonly used to find equation of lines were investigated. They were the point-slope form, which is y minus y1 equals m times x minus x1, the slope-intercept form, or y equals mx plus b, and the standard form, which was ax plus by equals c. Now the important thing to remember with the standard form that is not listed out here is that to have standard form a, b, and c, which are the constants or the coefficients in the equation, are all integers. And just as a little bit of review, the integer set is the set of basically positive and negative whole numbers, which implies that we don't want fractions in our equation in standard form. Of those forms, the one that was especially helpful when we were given the slope of a line and a point on the line was the point-slope form of the equation. And that's because if you're given a slope, that directly will substitute in for m in the point-slope form. And if you have a point and you consider that that point is x1, y1, you can put those values in to your point-slope form and you have an equation right away. So again, m is the slope and x1, y1 is any point on the line. Note that when finding the equation of a line using one equation form, such as the point-slope form, you may be asked to put your final answer in another equation form. For example, if you are asked to put your final answer in slope-intercept form, you must isolate the y variable on one side of the equation. That's because the slope-intercept form, as shown in the previous slide, is y equals mx plus b. Notice that your y is isolated. If you're asked to put your answer in standard form, you must move your x variable, or your ax term, and your y variable, or your by term, to one side of the equation and leave the constant c on the other side, so that you have ax plus by equals c. Now again, the other thing to remember if you're asked to put your final answer in this form is that a, b, and c do need to be integers. So if you have fractions, you will have to clear fractions, and we will do several examples of that. So let's start with this example. Find the equation of the line with a slope of 2 that passes through the point 1, negative 3. Put your final answer in slope-intercept form. Now you can start either with point-slope or slope-intercept form to get this equation. But because this is set up perfectly for point-slope, that's what I'm going to choose to use to get this equation. So take the point that you're given and let that be x1, y1. And notice they also give us a slope value. In this case, slope is 2. So using the point-slope form, we've got y minus y1 equals m times the quantity x minus x1. Plug your values in for x1, y1, and for your slope, and you have y minus negative 3 is equal to m, which is 2, times x minus 1. Now at this point, you do have an equation of the line. Okay? So depending on what the problem was asking, maybe you could stop there. But this particular problem does ask you to put your final answer in slope-intercept form, which means because slope-intercept form is y equals mx plus b, that means you're going to have to move terms around and isolate your y. So here, let's just take care of this double negative. That's considered poor form. So minus a negative is the same as adding. That's going to be equal to, if you distribute your 2, 2x minus 2 times 1 is 2. Again, we're trying to get this in slope-intercept form, so I need to not add, but subtract. subtract 3 from both sides, and y is now isolated where y is equal to 2x minus 5. That is slope-intercept form, y equals mx plus b. And that would be our final answer for that problem. So let's look at these two examples, which are very similar. Find the equation of the line with a slope of 1/3 that passes through the point -6, 3. Now we're asked, though, to put our final answer in standard form rather than slope-intercept form. But the problem is started the same way. We've got a slope given of 1/3, and we have one point which we will label x1, y1, so we can use y minus y1 equals m times the quantity x minus x1. So we have y minus 3 is equal to 1/3 times x minus a -6. That double negative can be changed to plus a positive. Double negative is a positive. And then we can distribute the 1/3, which we do need to do because we want our final answer in standard form. So we've got y minus 3 is equal to 1/3 times x, which is 1/3 x, plus 1/3 times 6, and I'm going to put that 6 as a fraction so that I can multiply 1/3 and 6. Notice that since that's multiplication of fractions, if we look across the multiplication dot, there is a common factor, so we can take a 3 out. 3 divided by 3 is 1. 6 divided by 3 leaves us with 2. And so now if we bring this up here, we've got y minus 3 is equal to 1/3 x plus 1 times 2 is 2, 1 times 1 in the denominator is 1, and 2 divided by 1 is simply 2. All right, now at this point, we want to get our x's on one side, our y's on that same side, and our constants on the other, because we're looking for ax plus by equals c form, standard form. So I'm going to move my 1/3 x to my other side, and that will get rid of it on my right-hand side. Now my x and my y term are both on the left, but I need to move that minus 3 so that it's on the right-hand side with my other constant. So now I've got negative 1/3 x plus y is equal to 2 plus 3 is 5. All right, now at this point, we're going to have to clear the fraction because a, b, and c should be integers. So to clear fractions in an equation, we're going to look at all of the denominators in the equation. In this case, we only have one. And we find the least common multiple of all of the denominators in the equation. That's similar to least common denominator. In this case, there's only one denominator. It's 3. And what we're going to do to clear those fractions is we're going to take that entire equation and multiply it by 3, which, if you think about it in terms of distributive property, mean that each and every term has to be multiplied by 3, whether or not there's a fraction on that term. That's going to allow us to get an equivalent equation, but clear out the fractions so we can have an equation that has all integer coefficients and constants. So that's going to give us 3 times negative 1/3 x plus 3 times y is equal to 3 times 5. Clean that up. Here in our first term, that 3 is up in the numerator, so we're going to be able to cross-cancel those 3's out. Now do the math. We've got negative 1 times x is negative x, plus 3 times y, of course, is 3y, and that's equal to 3 times 5, which is 15. That is standard form, ax plus by equals c. Our x and y are on one side of the equal sign, our constants on the other, and we've cleared out all of our fractions. And so there's our equation in standard form. Next example says, find the equation of the line with a slope of -3 that passes through the point -2, 4. put your final answer now in slope-intercept form, which is y equals mx plus b. So again, we're given a slope value. Our slope is -3. We're given 1 point, so we'll let that be x1, y1. And we're going to use y minus y1 is equal to m times the quantity x minus x1 to start. So we've got y minus 4 is equal to -3 times x minus a -2. We've got that double negative again. Minus a negative is the same as adding a positive. And we can then distribute our -3. So we've got y minus 4 is equal to -3x plus a -6, or just -6 if you prefer. We want slope-intercept form, so we need to isolate our y. So add 4 to both sides of our equation to get everything on the right-hand side other than our y. And if we bring that up here, we'll get our final answer of y is equal to -3x. -6 and plus 4 is a -2. So y is equal to -3x minus 2 for our final answer on that example. But what if you were given only 2 points on the line and no slope? Can you use the point-slope form of the equation to get an equation for that line? And the answer is yes, but first you must use the slope formula to calculate the slope of the line. Since slope is rise over run, slope can therefore be expressed as the difference in your y values, or y2 minus y1, divided by the difference in your x values, x2 minus x1. So if you know any 2 points on a line, you can calculate the slope using the slope formula above. For example, find the equation of the line that passes through the points 1, 2, and 4, 6. Put your final answer in standard form. All right. Now this example is different because we're given 2 points instead of a point and a slope. So our first order of business is to take those points and find our slope. Label one of those points x1, y1, it doesn't matter which. Label the other point x2, y2. And knowing that the slope can be found by finding the difference of your y's divided by the difference of your x's. Okay? And again, order is not important as long as you're consistent. We've got here y2 minus y1, as I have it labeled, is 6 minus 2. x2 minus x1 is 4 minus 1. Do the math. 6 minus 2 is 4. 4 minus 1 is 3. And we have a slope then of 4/3. Now we have a slope. We also have a point. Actually, we have 2 points, and you can pick either one. Okay? We're now going to do what we did before. We're going to take the point-slope form of the equation. We're going to plug in one of the points and the slope we just found, get our equation. So we've got y minus ry1 is 2, because that's the point I've already got labeled as y1, is equal to 4/3 times x minus 1. All right, let's distribute that 4/3. So now we have y minus 2 is equal to 4/3 times x is 4/3 x, minus 4/3 times 1 is, of course, 4/3. All right, now at this point, I know that since they ask for standard form, I am going to have to clear out my fractions. So I'm going to choose to clear my fractions here. If you look at all of the denominators in the problem, you can see that both the denominators in the problem, other than understood ones, are 3's. So we're going to multiply that entire equation by that least common multiple, okay, which means each and every term will multiply by 3. If you don't multiply every term by 3, you change the equation into a different equation, and that's not what we're trying to do. So to distribute that 3, you get 3 times y, which is 3y, minus 3 times 2 is 6, is equal to, and I'm going to write this out longhand, 3 times 4/3 x minus 3 times 4/3. Now remember that 3 is up in the numerator, which means our denominators will cross-cancel out. And since they're both exactly the same, they both cancel out. 3 divided by 3 just leaves us with a bunch of 1s. So now we have 3y minus 6 is equal to 1 times 4 times x is 4x, minus 1 times 4 is 4. And notice in our denominators we have a bunch of 1s. Anything divided by 1 is itself, so we can ignore the denominators and just look at the numerators. Now we have an equation that does not have fractions. So to get it in standard form, we want our x and y on one side, our constant on the other. So I'm going to choose to subtract 4x from both sides. That's going to give me minus 4x plus 3y minus 6 is equal to negative 4. Then I'm going to move my 6, so add 6 to both sides. And we've got negative 4x plus 3y is equal to 6 minus 4 is 2. And there is our equation in standard form as we were asked. Let's look at another example. Find the equation of the line that passes through the points negative 3, 4 and negative 2, negative 5. Put your final answer in slope-intercept form now. Okay, so slope-intercept form, fractions are fine. We just have to have the y isolated. The initial step, though, is going to be the same. We need to know the slope by finding the difference of our y values and dividing that by the difference of our x values. So we're going to let this first point be x1, y1. Let this second point be x2, y2. Or vice versa. It doesn't matter. You can let negative 2, negative 5 be x1, y1 if you want to. The math in the end turns out to be the same. So y2 minus y1 would be negative 5 minus 4 divided by x2 minus x1 is negative 2 minus a negative 3. All right, I'm going to take care of that double negative. Minus a negative is the same as adding a positive. So we've got here minus 5 minus 4 is negative 9, and negative 2 plus 3 is 1, and negative 9 divided by 1 is negative 9, and that is our slope. So now we know our slope, and we know at least one point. We actually know 2, but we only need 1 in order to use y minus y1 is equal to m times x minus x1. So put your values in. I've got y minus 4 is equal to negative 9 times x minus negative 3. Once again, double negative is a positive, so that's the same as adding 3. So we've got y minus 4 is equal to negative 9 times x plus 3. Distribute your negative 9, and you've got y minus 4 is equal to negative 9x, and negative 9 times positive 3 is minus 27. Okay, equation form we want is the slope-intercept form, so we're going to add 4 to both sides. And I'm going to bring that up here. We now have y equals negative 9x minus 23. And that is our final answer in slope-intercept form. Okay, so let's look at equations of vertical and horizontal lines. Let's review slopes and equations of these two special case lines, vertical lines and horizontal lines. For lines that are horizontal or vertical, horizontal lines that do not change as you trace them left to right, and you would agree that as you move left to right, the y values or the function values do not change at all. There's no slant or steepness to that line, and so all horizontal lines are said to have a slope of 0. Okay? It doesn't go uphill, it doesn't go downhill, it stays level for any horizontal line. Vertical lines have infinite slope as you trace them left to right. Now, left to right is kind of hard to do because in a vertical line, there is no left to right movement. It's all up or down movement. You would agree if you're thinking about slope in terms of slant or steepness, you cannot get any steeper than vertical. You can't get any steeper than straight up or down. And since there is not a number to represent infinite slope or infinite steepness, the slope is said to be undefined. And mathematically what happens if you try to figure that out is you get division by 0. Okay? So the thing to remember is horizontal lines have a slope equaling 0, and vertical lines have a slope that is undefined. Since vertical and horizontal lines are special cases, their equations also are special. Vertical lines have an equation of the form x equals c, where c is a real number and the x-intercept is at the point c0. So the thing to remember here, because this is kind of a formal definition here, is that with vertical lines, there is no y variable. It's going to be x equals something always if you have a vertical line. And remember, with a vertical line, slope is undefined. So over here, in this example, we have a vertical line. Our slope is undefined. Each and every point on there is going to have an x value of positive 4. And you can test that if we look at some of those points. For example, this point here would be 1, 2, 3, 4 to the right, and 1, 2, 3, 4 up, 4, 4. And if you looked at the x-intercept, this ordered pair here would be 4 to the right and 0 up or down. If you look, let's say, at this point right here, you'd be 4 to the right and 8 down. Notice that the one thing that all of those points have in common is that x is equal to 4. Y, on the other hand, can be anything you want as long as x is equal to 4. So vertical lines are always missing a y variable, and the equation will always be x is equal to whatever the x value is for any ordered pair. Horizontal lines have an equation of the form y equals c, where c is just a number, and the y-intercept is at the point 0, c. Notice that there is no x variable in those horizontal line equations. And again, we give an example right here. The equation here is y is equal to 4. Notice that the slope is 0, because slope of any horizontal line is 0. And if you look at ordered pairs, we'll look at a couple here. This ordered pair right here is 0 left or right and 4 up. This ordered pair right here is 2 to the right and 4 up. And again, what do those points have in common? The thing that's common in both of those, and in fact any point on the line, is that y is going to be 4. So knowing that, let's find the equation for these 4 examples. The top example says, write the equation of the line containing the point 5, 1 with an undefined slope. All right, you know that an undefined slope, which is what they say here, means a vertical line. And vertical lines are always missing a y variable. So if you have a vertical line, the equation is going to be x equals something. To figure out what x needs to be, just look at the ordered pair you're given. You're given an xy ordered pair, but you know the y isn't important because in this particular equation, it's only the x variable that appears. So here our point is x equals 5, and therefore that's our equation as well. X is equal to 5. Second example, write the equation of the line containing the point -2, 3, which of course is an xy ordered pair, with a slope of 0. Slope of 0 indicates horizontal line. A horizontal line is always missing an x variable, and it's always y is equal to something. So look at the ordered pair, figure out what the y is equal to, because the y is going to be equal to the same thing for any horizontal line. And we find that y is equal to 3. Third example says write the equation of the vertical line. Okay, so they tell you right there it's a vertical line. That means you are going to be missing a y variable, or the equation is going to be x equals something. Again, look at the ordered pair. You've got x comma y. Y is not a factor. X in this case is equal to 1/8. So you have an equation of x equals 1/8. And finally, write the equation of the horizontal line. Horizontal line means you are missing an x variable. Therefore, your equation is going to be y equals something. To figure out what y is equal to, look at your ordered pair. X is not important. Y is equal to 2. All right, so now let's look at parallel and perpendicular lines. Parallel lines are lines that have slopes that are equal to one another. So, for example, if you were asked to find the slope of a line that is parallel to the line y equals 3x minus 4, the first thing you would need to do is find the slope of the given line. Now in this case, that's fairly easy to do because this is in slope-intercept form, or y equals mx plus b form. And you know that in slope-intercept form, the slope value is simply the coefficient of your x variable. So in this case, our slope is 3 for our given line. Now, if the slope that's being asked for is parallel, parallel slopes are always the same if you're comparing lines. Okay? So if the slope of our given line is 3, then the slope of any parallel line will also be the same, which in this example is 3. Conversely, perpendicular lines are lines that have slopes that are negative reciprocals of one another. So for example, if you were asked to find the slope of a line that is perpendicular to the line y equals 3x minus 4, notice this is the exact same equation as above, so of course the slope of our given line is the same. We're starting off with a slope of 3. But now, in order to find a perpendicular line, we're interested in taking that slope and finding the negative reciprocal. So let's start with finding the reciprocal. Okay? Reciprocal of any number is simply flipping the number over. Your numerator becomes your denominator, and your denominator becomes your numerator. So 3, which is the same as 3 over 1, the reciprocal, if you flip that over, flip it over, becomes 1/3. And then if you take the negative of that, and negative just means change the sign. So if it's positive, it will become negative. If it's originally negative, it will become positive. Okay? The negative of a positive 1/3 then is a negative 1/3, and any line that is perpendicular to y equals 3x minus 4 will have a slope of negative 1/3. So let's apply that to writing an equation dealing with parallel and perpendicular lines. Now these are classic problems. They come up in nearly every algebra class you ever take, and also occur in some of the calculus classes you'll take. So it's important to be able to do these. Luckily, if you can do one, you can pretty much do any of them because they all set up the same, and there's a summary of steps on this slide that we're going to look at and then apply to several examples. So here's the problem. We want to write the equation of the line containing the point -4, 3, and parallel to the line 6x minus 5y equals 4. Write the equation in y equals mx plus b form. So here's a summary of the steps we're going to use, and then again, we'll do several examples of applying this to parallel and perpendicular line problems. Your first step is to always take the line that you're given and rewrite the equation in slope-intercept form if needed. And in this example that we're going to do first, notice that the line 6x minus 5y equals 4 is given to you in standard form. So we will have to rewrite the equation in y equals mx plus b form. After you do that, we're going to identify the slope of that line. Then our next step is to find the slope of the unknown line, knowing that parallel lines have equal slopes and perpendicular lines have negative reciprocal slopes. After that, you now know a point and the slope of the unknown line you're trying to find. So as in the previous examples, we're going to find the equation of the line using the point slope form. Y minus y1 equals m times x minus x1. And then we'll have our equation, but we'll want to put our final answer in slope-intercept form, just because that's normally considered a better way to put your final answer for these problems. So, same problem. Let's follow those steps that were listed out on the previous slide and solve this problem. Write the given equation, which is 6x minus 5y equals 4, in slope-intercept form. That's our first step. So start with what you're given. You've got 6x minus 5y equals 4. We want to isolate our y, so we're going to subtract 6x from both sides. That's going to give us negative 5y is equal to minus 6x plus 4. Now we want the y by itself, so we need to divide each and every term by negative 5. And that will cancel out, of course, on our left-hand side. And clean it up. We now have y is equal to negative 6 divided by negative 5 is a positive 6/5 x. And I'm going to separate the x out from our fraction. And then plus 4 divided by negative 5. Adding a negative is the same as subtraction, so I am going to write that as subtraction, minus 4/5. So that's our equation, same equation, given in slope-intercept form. Now our second step is to identify the slope. Okay? So if you have the equation in slope-intercept form, that's an easy thing to do because the slope will always be the coefficient of our x variable. So in this case, the slope of our given line is a positive 6/5. Third step, find the slope of the unknown line. And that also is very easy because if we know the slope of our given line, okay, the slope of our given line ended up being a positive 6/5. The slope then of our unknown line also will be a positive 6/5 because parallel slopes are the same. So step 4 says, now you know a point and the slope of the unknown line, so you can find the equation of the line using y minus y1 equals x times x minus x1. Okay, so we've got a slope of positive 6/5, and we have our point, which was negative 4, positive 3. So that's going to be our x1, y1 value. So we get y minus y1, which will be 3, is equal to our slope, which is a positive 6/5, times the quantity x minus x1, or x minus a negative 4. All right, and we're going to do that math. So we've got here a double negative is the same as adding a positive. Distribute the 6/5. So y minus 3 is equal to 6/5 times x is 6/5 x plus 6/5 times 4 is the same as 6/5 times 4 over 1. So now we have y minus 3 is equal to 6/5 x plus 24/5. And the final instructions say to rearrange the equation into slope-intercept form. So what that means is we're going to have to add 3 to both sides of that equation. So we've got y minus 3 is equal to 6/5 x plus 24/5. Add 3 to both sides. And over here, notice that in order to add those two values, we are going to need a common denominator because we're adding fractions. So we're going to build up that second fraction. So 24 plus 15 gives us y equals 6/5 x plus 24 plus 15 gives us 39 in our numerator. So we've got 39/5 for our final answer in slope-intercept form. Okay, so let's do another example. Write the equation of the line containing the point -4, 5, and perpendicular now to the line 7x minus 2y equals 1. Write the equation in y equals mx plus b form for your final answer. So step number 1, rewrite the given equation into slope-intercept form. So we've got 7x minus 2y equals 1. We want to isolate y, so subtract 7x from both sides. That's going to give us -2y is equal to -7x plus 1. Now if we take that, and I'm going to rewrite it here, and divide everything by -2, that will give us y equals double negative is a positive 7/2 x minus 1/2. So there's our equation in slope-intercept form. All right, now identify the slope of the given line. The slope is always, in slope-intercept form, the coefficient of your x. So the slope of the given line is positive 7/2. Third step, find the slope of the unknown line depending on what the question is asking. Now this is a perpendicular system, and perpendicular lines have negative reciprocal slopes. So the slope of our given line is 7/2. We're first going to find the reciprocal of that, which just means flip it over. So that gives us 2/7. And then if we take the negative of that, which simply means change the sign, we're going to have a slope of -2/7 for our unknown line. Now you know a point and a slope of your unknown line. You can use that information to get your equation. So we know that our slope is -2/7. We just found that. And we know that our point, because the problem gives us this, is -4, 5. So that's going to be our x1, y1 value. So we get y minus y1 is y minus 5 is equal to our slope, which is -2/7 times the quantity x minus our x1 value, which is -4. Double negative is a positive, so distribute. We've got y minus 5 is equal to -2/7 x plus -2/7 times 4, or 4 over 1, will give us y minus 5 is equal to -2/7 x minus 8/7. Final step, rearrange that equation then into slope-intercept form. So we're going to solve it for y, and so we're going to add 5 to both sides to isolate our y. I'm going to make that 5 into a fraction so I can get a common denominator. Multiply top and bottom by 7. Notice then here, 5 times 7, of course, is 35. And if we subtract 8 from that, 35 minus 8 is a positive 27, and that's all over 7. So we've got y equals negative 2/7 x plus 27/7. And there is our equation that is perpendicular to the given equation in slope-intercept form. And that brings us to the end of Module 15, Section 8.1. So you should now complete the homework for Module 15, Section 8.1, found in my math lab. And when you have successfully completed the above homework, proceed to the video for Module 15, Section 8.2.